Hello. Okay. I think we can start our class today. Okay. So today we go to another module. This one called Principal Component Analysis. You can say that is the PCA, and this one is very basic and very important for you if you want to study further. Example, you want to study machine learning or AI, artificial intelligence. This one is a basic knowledge, basic for you. Okay, so I will post the slide on the e-learning for you after the class. Okay, so what can the PCA can do? So they can do. They have three main functions. First is to project a data from one plane to another, from one space to another space. And the second one is to do the image recognitions. Yeah. And the third one is to do the image compression. Okay, so let's have a look at the first function. Okay, let's see on the picture. Yeah, the picture on the slide. Okay, and the picture on the left hand side. Yeah. Okay, so we can see that's indeed the camel, right? Camel. So camels, if you look at the back of the camel, right, you cannot see all the, I say, the structure or all the information of the camel, right? So if you change the view angle from this position, so you can see more information about the camel, right? So this one is the function of the PCA. It can change the data from one space, one coordinate to another coordinate for better illustration, for better viewing. Okay, for better analyze. So how can it do that? And it will based on basic knowledge. It's either about the eigenvector and eigenvalue. Okay, so I think that you have to study. You have to if you forget what is it, so you can study it after the class. Okay, so in the PCA, these two parameters are very important: eigenvalue and eigenvector. Okay, so how to obtain it and how to change the data from one space to another space. Okay, so okay, so this one is the example. Okay, example, you have the data here, okay, the data. Okay, so this is the data, and example, this is the space x, o, y. right? And example here, right? If you project it on the plan, on the all x y coordinate, right? This one may be too near, right? This one is too near. The x is too near, right? So this one is make you difficult to recognize which one the classification of each one. Okay, so they propose that we will change the coordinate from x or y here into another, we call this the a1, a2, and this is 0, 1 here, 1 here. Okay, so that means you will project it on this one, on this line, okay. Right, we'll check on here, okay, check on here. Okay, so now we will study where how can we have the E1. This one is the vector, and this one is the vector. So this one is the eigenvector. So in this data, we have two eigenvector. Okay. So how can we have the eigenvector from whole of the points here? Okay, let's go. So to do this, we have to follow a step. Okay, a step. The first is we collect the data. Okay, collect data, and then we do the average. And then we shift all the data. We will shift all the data back to the center, back to the average center. Okay, and then we calculate the covariance matrix. We call this ma chẳng hiệp phương sai, covariance matrix. Okay, so from this covariance matrix X here, we will calculate the eigenvalue and eigenvector here. Okay, and then we can present the data in terms of just one eigenvector or two eigenvector or three eigenvector. It depends on you. Okay, after that we will project the data again on the new coordinate here, this by this formula, and then we can compare it with the old data. We can compare it. Okay, so let's go to the example how to do it. Okay, this one first. Okay, the first one is we have this data. Okay, so now we want to project the data onto the eigenvalue and eigenvector here, right? Okay, the first one is what we do, collect all the data here, right? And then calculate the mean, right? So we calculate the mean data on x coordinates, y coordinates, right? How can we calculate? Just sum all of them, right? And then divide by the number of the data. So we will have the x1 bar and x2 bar here. Okay, and then the next one is we shift the data, right? We shift the data, the old data, into the origin of the new coordinates by the minus, right? So example here, 2.5 minus 1.81 is it 0.96. Yeah, so this one divide minus this one, we have this one. Okay, and then after that we will have the mean data of all the point here. Okay, so this is the second step. And then what is the third step? The third step is to calculate the covariance matrix, right? Covariance matrix. Okay, so this one, how to calculate the covariance matrix? Example, this one is the A matrix. A matrix, right? 0.69, right? 0.49 minus 131, right? So on, right? And so on. Okay, so we form this one a matrix, and then we calculate the formula. What formula? X equal to AT multiply A, right? Is it? Yeah. Okay. So we will have the covariance matrix. So this one is the X matrix. Sorry, this is A matrix, and this is the X matrix, right? X matrix. Is it? Okay, let's see. A matrix here is what is the size of this matrix? One, two, three, four, five, six, 7, 8, 9, 10, right? So this is 10, sorry, 2 by 10, right? By 10, right? And AT, this will become 10 by 2, right? So the result here is 2 by 2, right? Okay. So after this step, we have the covariance matrix here. Okay. And the fourth step is we calculate the eigenvector and eigenvalue. Eigenvector and eigenvalue. Okay. So how to calculate it? How to calculate it? Okay. If you already how to say study the previous lesson, right? I already introduced you how to calculate it, right? This is very easy, just minus lambda here, right? And this is minus lambda here, right? And then multiply this one and this one, right? And then we solve the equation, and then we can calculate the lambda 1 and lambda 2 here, right? And then we can calculate the eigenvector and eigenvector, right? Okay. So this one, I think that you have to go back and do the research by yourself. Okay. So let's assume that you already calculate the eigenvalue and eigenvector here. Okay. So the next step is we will project, right, the old data to the new coordinate, right, to the new coordinate. So as I said before, you can project the data here using just one eigenvector or both two eigenvector. Okay. So let's have a look at the eigenvalue here. The first one is 1.2 and the second one is 0.049. So that means if you just use one lambda, it's enough for you to represent the old data, because the question here, which data have the higher value, that means they will keep the more important feature of the image, the more important feature of the coordinate. Okay. So we can project the data on the new coordinate by just use one eigenvector or two eigenvector here. Okay. So let's see. if we use both two eigenvector, right? We will use this formula. So this one is the old data, our old data. So we will project it on the using two eigenvector, and then we will have the new coordinate here, right? New coordinate here. Okay. But if you just use one eigenvector, one eigenvector, you just have this one, right? One row like this, right? One row like this. Okay, and then based on this one, right? Based on this one, I can tell you the difference. Okay. Example here. By looking at this one, I can say that this one and this one, right, have the same, are the same class. This one are in the different class because it's very small here. Okay. So this is one application of the project on the new coordinate. This will help you to analyze the data better. Okay, because this is a very simple example with just fields of data. If you have hundreds of data or 1,000 of data, you will have the problem. Okay, so that means you have to change it into another space for better viewing. Okay, so this is the example. Okay. Okay, so we go to another. Okay, I will. This one is just some more description of the previous one, so I will skip it. So don't worry. Okay, the next one. The next function of the PCA is to do the image recognition. Example, we have three images, right? Three images, at the data, right? And if I have another image, right? I want to check this image. This one is similar to this one, or this one, or this one. Okay, so this is the recognition. Okay, and okay, let's have a look at the methodology, how to do it. Okay, so this is the limitation of the template matching. Okay, this is the you can read and then analyze by yourself, right? I will go to directly the mathematics because it's a little complicated and it takes a lot of time. Okay. Okay, so let's do it. Okay, example, I give you three images, right? Three images. I1, I2, and I3 here. Okay, and then if later I give you another image, I4, I will tell you that which this image will similar to which image here. Okay, so in the PCA, we need to do the training first. So what will we do in the training mode? First, we do the training to extract the most important feature of those data. And then we just compare the most useful feature of those data and useful feature of this data. So it will help you to reduce the time efficiency. Okay, so let's do it. First, collect the data. Okay, and then represent the data into this form. Okay, 1 2 4 5. Okay, 1 2 1, sorry, 1 4 2 5, right? Another student will do 1 2 4 5. Is it okay? Yeah, it's okay, no problem. It's just to present the data. Okay, you can present the data as your rules. It's okay. Okay, so first just present the data in this form. Okay, and then the second step, what will we do? What will we do? We do the mean, right? We do the mean, right? The mean value, right? The mean value, right? So this is the mean value of this one, right? 1 2 and 3. Okay, okay. Is it 1 lot 4 lot 2 lot 5 divided by 4, right? This is 3, right? Okay, okay. And then the next one is we will calculate the errors. Or this one is the shift, right? Shift all data into the origin of the new coordinate, right? Okay, and then after we do this formula, we have this one, the 1 2 3 here. Okay, okay. The next one, we do the covariance matrix, right? Covariance matrix. It's similar to previous example, right? Okay. Here we collect theta 1, theta 2, theta n into this column, right? And then we do the AT, right? This one, right? This one. And then we have the covariance matrix C, right? And from this one, we calculate the eigenvector and eigenvalue here, right? This one, it should have three eigenvalue and 3 eigenvector. But here, we just have 2 because one eigenvalue becomes 0. One eigenvalue becomes 0. Okay. Okay. So after this step, we have 2 eigenvector and 2 eigenvalue. Yeah. Right. And then we find the how to say, the feature of the data. And to find the feature of the data, we calculate by this equation. Okay. So this one is the vector. In the vector. After we do this step, okay. After this step, okay. And after this step, we do normalize this one, right? U1 and U2, and then we have U1 and U2 here. Normalize. So this one is the very important feature of the data, of our data here. So later we just use this one to compare or to do the recognition. Okay, so the next phase is to recognize, right? Recognize. So if I give you another image, right? I4 here, right? Another image, right? So let's see. So we also do the similar step up to step 3. So that means represent this one into I4 into column, right? Into column, right? And then do the mean, right? Do the mean of this one, right? And then minus, right? then minus, and we shift, right? We have the theta, the phi here, right? Phi here, okay. Okay, so let's do. So example, I give you this image, right? This image. Or another image, it's okay. Another image is okay. So we will check it. We will check this one. We will check this one. Is it similar to another previous picture? Okay. Okay. So first we represent this one into this formula. Okay. This formula. And then what will we do? Right? Do the shift, right? Shift this one, right? And then after this step, we have this matrix. This matrix. And then we will do the omega here. Oh, very important here. Omega will equal to u1, u2, multiply this one. Multiply this one. Where is u1 and u2? U1 and u2 is this one. This one, okay? This one. Okay. And then after this step, we have the omega here. Yeah, here. Okay. Okay, let's on the image one, on the image one, we have the omega 1 here. In the image 2, we have the omega 2 here. Image 3, we have the omega 3 here. And then we just use the new one here, minus with h1 here. Here the error. Here is the error, okay? And then after this step, you can see that the error here is very small. Very small. So that means I4 nearly similar with I2 because this is smallest. Let's go back. Is it this one similar? This one similar? Is it? Yeah. Okay. So from this example, right? When you go back home or you after the class, right? You can change the I4 here, right? Another matrix, right? Another matrix, and then you can check is similar to which one, right? So this one is the image recognition. Using PCA. Okay. So do you have any questions on this one? Up to this step? Normally, in the offline class, I will give you another matrix, and then you can check by yourself and tell me the result. Okay. Okay. So if you don't have any more questions, we will go to another. Okay. I have just introduced you two functions of the PCA. One is change the space, right? Change the coordinate, and another is the image recognition, right? And another important feature, important function of PCA. This is image compression. Okay, let's have a look at the example. Okay. I will explain to you based on the example. Let's see better. Where is it? Yeah, here. Okay. Okay, here. Okay. Okay, here. So example, I give you this image, right? And then compress the image. What does it mean, compress the image? Compress the image, that means we can reduce the size of the image by just using the most important feature of the image, but still maintain the quality of the image. Okay. Okay. So how to do that? It will based on the eigenvector and eigenvalues. Okay. So let's see. Example, I give you this image, right? And then ask you to reconstruct this image by using just one eigenvector and three eigenvector for comparing. Okay, so let's see. First, what will we do? List all the feature, right? List all the feature. List all the feature, and do the average, right? Do the average. Okay. So this one example here, plus, and then divide by all the feature here, right? All the feature here. Okay. So after this step, we will have this one. Okay. We will have this one. And then we will shift the data, shift the data. And then we will calculate the covariance matrix. Covariance matrix here. Okay. So the covariance matrix is this one. Okay. Just take this one and transpose and then multiply, and then you have this one. Okay. And then from this one, we will calculate the eigenvector and eigenvalue. How to do that? Okay, you can use the software MATLAB to do it. Okay. So after this step, you will have the eigenvector and eigenvalues. So this is the eigenvector, very long. And this one is eigenvalue. This eigenvalue. Okay, so from this one you can see that, right? The eigenvalues, this one is biggest, and smaller, and then smallest here. Okay, so the question is ask you to reconstruct the image using just one eigenvalue and three eigenvalue. Okay, so first case you just use one eigenvalue. Why? Because here you can see that this one is very big comparing to the remaining, very big. So just use this one. Is it enough to reconstruct the image? Okay, let's see. If we use just one eigenvector, one eigenvalue here, so one eigenvalue here, we will choose this eigenvector here, this one is the eigenvector, and this is the eigenvalue of this eigenvector here. Okay. And then if you just use this one, and here is you three, so that means we use three eigenvector here. Okay, so that means we use three eigenvalues here. Okay, so this one is 3 and this one is 1. Okay, and then we reconstruct it. Okay, we project the old data, the data on this one, So we just use this formula. Okay, and then we have this one, and if we use this one, and then after that, this one is 3 eigenvector. We use this one. We have 3 U1, okay, 3Z, okay, and then we reconstruct the image by this formula. Okay, so this formula is, if we use the 1 eigenvector, we will have this one. And if we have 1 eigenvector and then do the rest whole, you have this image. And if you use 3 eigenvector, this is this one, and you rest whole with T here, and you have this image. Okay, and then log it, show it, and then what will we have here? Okay, you can see this one is the original. Okay, this one is the original. And this one, if you just use 1 eigenvector, this one is the image, right? It reduce the size. And here is 3 eigenvector. So you can see that if you use 3 eigenvector, it is better than using 1 eigenvector, right? It's nearly similar, right? Just different on this pixel, right? Just different on this one. Okay, this one have, and this, but this one don't have. Okay, so this one is the image reconstruction or image compression. Okay, so this one is the procedure, how to compress the image, okay, or reconstruct the image. Okay, I think that's up to this step. You will not have any question, but when have the exercise, you will have a lot. Okay. And how to obtain, example, I have the covariance matrix here, right? And how to obtain this matrix? Okay, you can use MATLAB. You can use MATLAB or OpenCV. It depends on you. It's okay, no problem. Okay. Okay, so this one is the procedure to do the image compression. Okay. And here is the example on the real image here. Let's see. Oh, where is it? Ah, okay. Ah, maybe I already deleted. Yeah, because this is for another example. So okay, So okay, so this one is the example, right? Example of the image recognition. Sorry, image reconstruction. Okay. So I already introduced to you about the basic information, basic knowledge about the PCA, right? It's just around. If you have more, how to say, read somewhere more information about the PCA, it's just around the knowledge that I have explained to you. So it's okay. So so do you have any questions on the on the on this one? Okay, so let's have a look at another example. Okay, this one is another example for you. Example, I have this one. And in the previous lesson, you already study how to calculate the angle, right? The angle of the block, right? The angle of the block. And in the PCA function, they also help you to find the angle of the block. They also you can find the angle of the block. So how? So let's see. Example, I give you this one, right? And then find the angle of the plot here and the plot here. Okay, so let's see. So we list all the coordinates, right? All the coordinates of all the point in the table here, right? We have two table, two coordinate, two set of coordinate, right? And then we do the mean data, right? And then we do the we calculate the covariance matrix, right? And from the covariance matrix to covariance matrix here, we calculate the eigenvector and eigenvalue, right? Eigenvector and eigenvalue, right? And then from this one, you can calculate the angle here. Just use this function. Let's use this function. This one. This one, is it this one? Here. Is it? Just arctang. The lower and the upper. Okay. And then you have the angle. Okay. And then you can check it with your result when you use the blob detection. Okay. Hull moment. Okay. So just this one it have you to calculate the function. Okay. And the remaining is just the coordinate of the this one is not this one. Okay. Yeah, this one is, yeah, this one. Yeah. Okay. Just calculate the angle. Okay. Okay. So this is the introduction about the PCA. Okay. And about the histogram of gradient. It's a extra. You can read by yourself. And it's just the extra knowledge. You will not meet it in the exam, so don't worry about it. if someone want to study about a histogram of radian, okay, you can read it and then you can ask me the question. Yeah. Okay, so I think that's this is all the information I have explained to you today. So do you have any more questions? Okay, I want to say something. Uh, uh, I do not remember that I have tell you or not. I have told you or not. Uh, in your how to say about the score of the exercise. About the score of the exercise. Okay, where is it? Okay, up to this step, you have already have 4, right? You have 4, right? And the exercise you have just submit, right? It's the candy, right? It's like this, right? And you will have another exercise called the PCA, right? And you will have another is the camera calibration, right? And then 3 exercise will become your big exercise, okay? Your big exercise. Okay, the average of 3 score of this 3 exercise will be your big exercise, okay? So that means now you already have the score for the group exercise. Okay, you already have the score for the group exercise here. Okay. And as you see, oh, your score is very, very high. Okay, so don't worry about the score. Okay. Okay. Yeah. Is it? Maybe I make the some uh, wrong sum. Okay. Wait a moment. Wait a moment. Let me see. Why? No, already. Is it? Is it your exercise?
No, sir. I think it's the homework 3 is the third exercise you gave us.
Wait a moment. Maybe I already upload wrong file. Wait. I have a lot of. Wait. Is it this one? Wait a moment. Uh, mm,
It's the one with the black and white picture of some circle and square.
The morphology, not the mechanic.
Ah,
Yeah,
morphology.
morphology
Ah,
one.
yeah, yeah. Okay, okay. Morphology. Okay, okay. Okay. Morphology 2 1
One.
1. So this one, right? Is it
Yeah,
this one?
that's the right one.
That's right. Okay. So what do you want to ask me?
I just want to ask. We couldn't do question 3D, so that question only costs 0.75 points.
Yeah.
Yeah, so you did the write down that we have any mistake of the order's question, so the point should be 9.25, right?
You mean that the score? The score? Okay. Let
Yeah,
me
yeah.
see. Okay. Let me see. Your group
Number 3.
number 3. Yeah, I already how to say explain to you, right? Number 3, right? This one, right? Is it?
Yeah. That, that's one, but I think I written the right name. Is it nhóm then dash 3?
Yeah, yeah, right. 1, 2, and 3 here, right?
Yeah.
Yeah.
That's right. Oh, you written that the name is incorrect, right? Okay, let me check.
Oh, yeah. Okay.
So you mean the name need to be nhóm dash 03, so
Yeah.
when I
Yeah.
miss the zero is not right.
No,
Okay.
no. You write wrong. How to say? Let me see.
As written is nhóm then dash 3.
Really?
Is yeah.
Wait. You for score 1, right? And you are the person who submitted you, right?
Yeah, that's right.
Is it?
Yeah, that's right, sir.
No, you had wrong. Wrong. You should write like this. Is it? You have to write the group number here. Right, the group number here. Okay.
Yes, but I written like that, just like that. Why?
No,
It,
you didn't write like that. Oh, this one? Ah, okay. Ah, okay. I see. Ah, oh,
wait,
sorry.
wait, wait, wait a
Okay.
minute.
Okay.
Uh,
Okay, I understand.
yeah, miss the dash right there.
Okay, I understand. Okay. Sorry. Okay. Okay. Okay.
Yeah, but homework 4 and 5 I didn't make that mistake. Yeah,
Okay. I
yeah,
see.
it's just
Okay. Okay. I know. I will change the update the score for you. Okay.
oh,
I know.
okay, thank you,
Yeah.
sir.
Okay.
Thank you.
Okay, I already update in the Excel file. I will update online later. It's okay. Yeah. Okay, so if you don't have any more questions, we can dismiss the class now.
So do you have the answer for those questions that we couldn't do from the homework file?
Good questions.
I mean, some of the homework we couldn't do, like
Okay,
that 3D.
so the
Can
answer,
can
the
yeah,
answer.
can you?
Yeah. Okay. Let me
Yeah.
see. Uh, let me see. Uh, the homework three. 3D, right? 3D.
Yeah, finding the inclined lines, but the noise you gave is so large, so I cannot filter it out.
Is it this one?
Yeah, that's right, sir.
That's right. Where in D?
I mean, I couldn't do it. Could you show us the
Okay. You
answer?
couldn't do it? Yeah, okay. I understand. So what is the questions? Let me see.
Is about finding the inclined lines on the input, but the noise is kind of larger than the line, so I could not filter out the noise.
Let me see. Um, let me see. Where is it? It was moment. Okay, yeah. Here's the sound. This. Okay, wait a moment. Why? Okay, here. You cannot find this one, right?
Yeah, that's right. Yeah.
Okay, let's see. Here. Okay. So what is your problem? You cannot do. Why?
Because the noise, the dot It's really large in some. It's larger than the inclined line, so I could not filter out the noise when if I show the inclined line, the noise will be in that image too.
In that image too?
Yeah.
Because have you find the how to say the how to say the kernel for the for this one?
Yes, yes, I did that too, but it couldn't. Yeah. Uh, I don't know why that couldn't do it. Because the noise contain that kernel too, I guess.
No, why? Okay.
So you just create a kernel with the inclined line just
Yeah,
like that, and you solve.
yeah, correct. Yeah.
Yeah, last yeah, but I don't know. Last time I did that, the noise is included in that too.
Really?
Yeah.
Let me have another for you. It's okay. Just choose uh, the the kernel, and then you can find it. Yeah. Previous one, some student already just he just find the kernel. He just find the kernel, and then he can find the all the incline lines. Yeah, straight line, incline line. Yeah, he just use the kernel.
Oh, okay. And can I ask what size is the kernel you use?
A little big, a little big, a little
Ah,
big.
big. Oh,
Yeah. I remember he used 7 by 7. Yeah.
757.
Yeah.
It's based on the initial image size too.
Yeah. Yeah. Correct.
Yeah,
Correct.
I think I crop is too small, so the
Really?
yeah, so the pixel is not that clear. Yeah,
Ah. Okay.
yeah.
I see.
Okay, that's okay. I just want to know the method.
Yeah.
It's the
Yeah.
same as I use, and it's okay.
Okay.
Thank you.
Yeah. Just use the kernel. Yeah. Just choose the kernel, and you just choose the kernel, and then you can find everything here. Yeah.
Oh, okay, so that's all.
Okay. Yeah. Okay. So we do you have any more questions? Any other people? Other people? Okay, so if you don't have any more questions, we can dismiss the class, right? And then wait for another exercise. Okay.